All right, so let's get started. So today, I was just saying this title is kind of a mouthful, but data-driven mapping GIS using Google Maps and CartoDB. Basically, I've been working with my current client last couple of months. I work on a property management system for my client, STR. And recently, we've gotten into more advanced mapping and GIS capabilities in that product. Using Google Maps and a product I'll show you soon called CartoDB. And I thought it would be worthwhile showing everybody here. Mapping has become more ubiquitous out there on the websites and mobile devices. Everything's using maps nowadays. So this is a good skill to at least know about and to start to dig into. So I'll just start with a stupid quote here, but Jimmy Buffett, without geography, you're nowhere. Thought that was kind of applicable here. So real quick, we're going to just go over a little bit of introduction to maps. You guys may know some of this, but some of it is a background on what we're talking about here. We'll talk a little bit about Google Maps and the API. I'll show some demos and some simple maps and markers and so forth that you can create. And then I'll talk about a product we use out there. It's a SaaS product called CartoDB. And I'll show you some demos, some cool demos on that. And then we'll talk about some other mapping and GIS resources that are out there and available. So real quickly, mapping encompasses a lot of areas, but we're talking about paper maps, imagery, satellite images, street views, things like that, web maps, mobile maps. This kind of sounds basic, but it's good to go over what people use maps for. Really communicating a large amount of information in a relatively small area. So just like a picture is worth 1,000 words, same thing applies to the map. You really can express a lot more from data and analysis through a map sometimes than you can through just lists of data. We use maps to find patterns. We'll see some examples of that. We can view information over time on maps. So you've started to see these kind of maps where they'll show you, population increases or so forth on maps over a period of time, even weather, for instance. We derive new information. We find new things by just analyzing maps. Houses that are adjacent to other houses and how that affects costs in a neighborhood and things like that. Communicating ideas, status reports, and to compile geographic information. So you hear the term a lot nowadays, what GIS. So what exactly is GIS? So it's Graphical Information System. But it's really a system that encompasses these areas of spatial data entry, being able to input the geography information into some system, the management of that information, storage and management, so typically a database or some sort of repository to hold that information, retrieval and analysis of that information. The analysis is a big part, being able to apply algorithms to the geographic data to find things like, finding locations, for instance, within a radius. We'll see a couple examples of that. And then, of course, visualization functions. How do I actually visualize this information on a map or some sort of visualization? So what, though? What's the big deal? Again, by layering this information on top of a map, we can visually represent the data in a way that we could really have it understood by the large audience. And maps can reveal a significant data relationship that sometimes are difficult to comprehend or see by just looking at the raw data itself. So again, visualization is just like graphs, same idea there. So this idea of creating visualizations and getting data out of maps is not really a new concept. I like to bring up this example. In 1854, Snow actually mapped an outbreak of cholera in London. And then analyzing this information, you can kind of see in the middle of the map there on Broad Street, he's actually able to pinpoint a single well, single contaminated well that caused this outbreak. So this had really not been done before, or in this type of scale to apply to this kind of a problem, an outbreak. So GIS people and cartographers and so forth like to bring this up as a good example of using maps to analyze information. But fast forward to today, And we're doing the same thing, just using the modern technologies. Here's the current outbreak of Ebola in Africa. This website's called healthmap.com. It's really kind of cool. What it does is it mines social websites looking for keywords, you know, fever or, you know, bleeding from your eyeballs or whatever it is out there. And then based on that, it starts to map, like it is here, hot points in locations. They actually use this. This is actually picking up one of the original outbreaks of Ebola a couple of months ago in, Guinea. There was a couple of articles or, social networking postings that this thing started to map. So they actually used this map to start to pinpoint where the outbreaks were coming from. So very similar to what was happening back in 1854, the same thing's happening right now. And if you go to this website, healthmap.com, it'll show you over a period of time from when they started to identify it to now how this outbreak was spreading. So nice example of GIS in action. All right, so what we'll do now is just go over some web map and GIS terms and concepts. So some of this is good to know when you start to get into the API level and you start to work with these tools. Some of the concepts and terms here. So the first, term or concept is a map tile, and this is applicable to web maps. And you guys are all familiar, I'm sure, with Google Maps, maybe less familiar with Bing. But essentially all the web type of mapping tools out there use this concept of a web tile. And the tile is typically a 256 by 256 image, a relatively small file. And essentially they're going to put the images together in the, like you see up there at the top graphic there, to create the actual map. So they typically use some sort of coordinate system to identify each tile. So a popular coordinate system is the ZXY. So the Z is the zoom level, and of course the X and Y coordinates of that tile. Bing uses something slightly different called a quad key, but it's a similar concept, a way to identify each tile. The reason we use the tiles is, again, they're simple, they're efficient, they're small files, they cache easily on the browser. They can be loaded progressively and loaded simultaneously from the browser itself. So that's what enables Google to render a map so quickly, for instance, and the fact that it caches those tiles both on the server and the client side has almost an instantaneous response for you on the map. Another really big advantage of map tiles is that they can be stacked easily to create layers, and we'll see that in a few minutes. And an example, just real quick, is if you go to this Google Map or Google API URL here, you see that essentially it's going to show me a tile that's in the X coordinate 2, the Y coordinate 6, with a zoom level of 4. And when I zoom in on that, I see that it pulls back the tile itself. So this is an actual tile coming back. When you go to Google Maps, like in a Chrome browser or something, take a look at your network traffic that's going back and forth between your map, and you'll actually see these tiles coming back. It's really kind of neat to see how that works underneath. So the next concept we'll talk about is something called a base layer, or some people call it a main layer. Essentially, this is the base set of tiles that your map is rendering. So, for example, in Google Maps, it's going to be your street view, your earth view, your terrain view. However, there are a lot of different providers out there that are providing tiles nowadays. OpenStreetMap is a crowdsourced project, open source project out there where people contribute these base layer tiles so you can start to construct your maps. So there'll be everything from just different ways to visualize the streets to different terrains and so forth, different colorings of the base maps. There's another commercial product out there by a company called Esri called ArcGIS. ArcGIS happens to be, I would say, the grandfather of GIS systems. It started as it originally started as a command line tool way back when, and then it was a desktop tool, and now they're moving out to the web. They provide a good set of base layer tiles, and you'll see this product out there a lot if you use working with customers, especially state and local governments and so forth. The majority of them are using that particular product right now. And then there's many others out there that provide base tile, layer tiles, as well as you can actually make your own base tiles yourself if you had some special custom need. There's ways to do that. So the next concept is the layer itself. So you see that we started with that image base, which is my base layer. But I can actually now start to stack together tiles on top of each other with a transparent area to layer on top of a map. So for example here, Google Maps layers on traffic in Washington, D.C., which of course we have a lot of. So basically that's a tile on top of the base layer that has a transparent background, just drawing those traffic on the roads themselves. But because the tiles are the same size and they lay on the same coordinate area, they stack on top of each other precisely. So you can start to show, and you can see here on the left-hand side, you know, different features basically of the map using these layers. So we'll see some of those examples in a few minutes. There's certain file types out there at the bottom that supports layers. So you'll start to see these file types as you work with maps. A popular one out there is the KML or the KMZ. That's actually the Google map layer file type. It originally came from a product called Keyhole Maps, which is where the KM part comes from. You'll also have a file type out there or a set of files called the shapefile, and that's from the company Esri or the ArcGIS. We also have a JSON format for layers and geographic information, and that's the GeoJSON. So those are probably the top three most popular file types out there for GIS kind of information you'll run into. Then, of course, and you're probably more familiar with this, you know, on top of maps, we usually render markers and information windows or pop-ups. Those are usually rendered actually on the client side itself. And we'll see some examples of that. Then some other concepts we have and terms we use when we do mapping is on the left, we have something called a bounding box. Or sometimes you'll see a minimal bounding box. And this is getting a little bit more into the geography, algorithms and functionality, but essentially when you say a bounding box, it's taking some sets of features and finding a box that will contain all of those features within the box. So you can see here I guess there's 5 markers there. That's the bounding box that will contain all 5 of those markers. Sometimes that's important because we like to zoom in on that particular area, but be able to show all the features in the map. Also, when you want to calculate area or you know how much area contains those features and so forth, that's when you're going to use the bounding box itself. And then on the bottom we have a slightly different variation on that called the extent. And typically the extent is the area of the map that you want to show at a particular time. So you would describe an extent with top, left, right, and bottom coordinates. Or most of the times actually you're going to use the southwest corner and the northeast corners to define that box. But basically when people are saying extent, it's the area of the map you want to show at that given time. And finally, another really important concept are the actual feature classes, what I'm actually going to put on the map themselves. And from a geometry perspective, there's a few different types out there. There's the points and the multi-points. So this is when you're dealing with markers or groups of markers. You're going to typically describe them geometrically as a point, which will have some sort of coordinate, latitude or longitude or X or Y coordinate. We have lines and polylines. So this is when you saw earlier being able to lay out on top of streets. So we describe those as lines or multiple lines, polylines. So of course a line would have a beginning point and an ending point. Polylines would have multiple beginning and ending points or multiple lines actually grouped together. We have polygons, and that's the lower left. So that would be describing, for example, the boundary of a property on a map, for instance. So the polygon is going to contain many points, closed area basically of points and lines. And then annotations, which are just labels on top of the maps themselves. So those are generally the features that you're going to be using on a map when you're working with the APIs and so forth. Okay, so any questions on that before we move into the API? Or okay. So first, we're going to go over Google Maps API. By no means this is the only mapping API out there, but this is probably the most familiar, most popular, the one that you're going to run into the most. The link there is to the JavaScript documentation. It is a JavaScript library, of course. It's got an excellent set of maps and imagery. You know, everybody's familiar with that map set. They're pretty accurate maps as far as, you know, directions and so forth. The satellite imagery is really good from that. And, you know, another killer feature, I guess, they have is the streets view. And we actually use that a lot in our property management software as well. Customers really like that. The API itself is really easy to use. So it's a really quick way to create a web map. It literally can be created in one line of code if you just want to place a map. But the API is fairly feature rich, so it allows us to do a lot of the things we just talked about, placing markers, drawing on the map, working with layers and so forth. And the last one is kind of the double-edged sword, I guess, is it is a free API. It's freely available to use, but I put the little asterisk there because like a lot of the Google tools or Google APIs, there are always limitations. So Google's going to limit, and you have to get fairly heavy in terms of volume, but Google will limit the amount of tiles you can serve per, I don't know how they measure it, per day or volume or what have you. There's limits to the size of the layer files you can upload. There's certain limitations because of the way the API works and the amount of markers you're going to place on the map because they're rendered on the client side and so forth. So keep that in mind when you're working with Google Maps. And this is actually, and we'll see when we switch over to talking about the CartoDB tool in a few minutes. This is one of the reasons we actually decided to switch off of using the Google Map API directly and to look at something a little bit more heavy duty in terms of, or less restrictive in terms of some of those capabilities, limitations actually. So I'm going to go walk through the code now. So all the code's available on my GitHub site. They're pretty simple kind of examples, nothing dramatic here, but this will actually be good if you want to just start out playing with maps. You can take that code and start to quickly visualize it and play with that stuff. So let's switch over to the demo. All right, so the first example here is, you know, the most simplest example you can have is using the API. Just bring up a Google map on your website and, you know, center it on a particular location. So here we are centered on Solution Street's office where we are right now. So if we take a look at that code, so to start off with the HTML itself, you know, it doesn't get more simpler than this. So what we're going to do is bring in, so this is Bootstrap for the styling, so that's not really required. But what we're going to do is bring in the Google Map API here, which is served by Google's CDN, the Google Map API CDN. And essentially, that's the only external library you really require in terms of start to use the Google Map API. The rest of this is just to support the demo. And then you're going to just create a div, essentially, in your website that has an ID, empty div. And that's where the map itself is going to be located. By default, it will expand this div to fill the entire viewport of your browser, but you can size the div. So if you want to contain the map within, you know, some location on your page, that's entirely possible as well. And then so as far as on the JavaScript side, to actually make this map work, really what we have is just this one call here. I instantiate the Google Maps.map object, and I give it the element, the div element that I want it to render into. And then I can set some default options. So in this case, I'm just passing in the zoom level of 20, which is street level view. And I also tell it to center on the location for Solution Street. So if I go into this base file here where I've externalized, you'll see this is the location in terms of latitude and longitude. So this is how we express latitude and longitude in this particular geographic system the location of Solution Street in terms of latitude and longitude here. And that's really it. And whoops. And once I run this code, it renders the map. Can't get any really simpler than that. So nothing too exciting there. So, moving to the next step, let's just make a marker at the location. So, this is a kind of an example where you might have a website, you want to locate some sort of property or location on the map. So there's not much more to doing this. Oh, I'm sorry, is it not nice? Oh, there you go, thank you, yeah. So basically what I did is I just added an add marker function here and passed in the location that I want to add the marker on top of. And you really need to do two things here. We just create a latitude and longitude position. So there's a latitude and longitude object in Google Maps. And then I actually create a mapper object here, passing in the location, and then the map object itself. And then as soon as I instantiate this, it will place the marker on the map. So that's pretty straightforward there. So progressively moving through the example, now I want a map with a marker, and then when I click on the marker, I want to show the pop-up. So this is pretty typical mapping functionality as well. And I want to render in the custom content inside that marker. So building on the example, so example 3. In my add marker, before I actually create the marker itself, I'm going to create an info window object. And info window takes a content property, which is HTML that I want to render into here. So here I'm using a mustache template, which I've externalized, but pretty simple, just a div here with the title, the street, city, and so forth in that marker and the URL, which is a pretty good pattern to implement. We do that on our my client's product, so we externalize the template for the info windows for the customers to customize themselves since it's a SaaS product. But see, I'm binding in the Solution Street office address and URL. Once I create the info window, on the info window itself, one thing to note about Google Maps is by default, you can open up as many info windows as I guess the browser memory can handle. But typically, as best practices, we would recommend only opening up one info window at a time. Google Maps requires you to manage that yourself, so they're not going to do that for you. So typically what you're going to do is have some sort of variable that holds what the pointer to the current info window itself. So here you see that on the info window, I added a close click event that when it closes, it'll clear out that variable. So now there's no open window available. So again, I create the marker itself, and then using the add listener event on the map for that particular marker object, for the click event, I'm going to first close any current info windows that are open by just calling the close function on the current info window. And then I'm going to show the new info window, sorry, by passing in the marker in the info window object itself and just telling the info window to open itself, passing in the marker so it knows the location that it could open onto. You can actually pass in a different location for the info window if you wanted to open it all the way on the side, for instance, or underneath. So all that can be customized. But this is a pretty, at least what we've used is a pretty typical pattern for how we manage and open up info windows in the system. So again, opening up the info window, closing it, managing that current info window itself. So moving on to the next example. So here is an example where I'm actually going to open up a bunch of markers. So what I have is, as far as data is concerned, I have this JSON file here, which contains, I think this contains about 1,000 properties that are actually located in the city of Detroit, and passing in some property information, parcel number, property address, and the actual location. So this is, again, more of a realistic example of mapping quite a few pieces of data on the map. With this example, you notice that when I brought the map up, it didn't move to where the markers are. Obviously, we're still in Herndon, right? We're not in Detroit. If I zoom the map out and, whoops, I didn't mean to do that. If I zoom the map out and then move over to Detroit, I have to move over like that and click. This is where, in a minute, I'll show you an alternative way to do this, where we use the bounding boxes and the extent to figure out where these properties are located, or the bounding box for these properties, and then setting the map onto that. So I just wanted to show you the difference there. But here you can see many markers set up on the map. Markers set up on the map at a time. And if I click on one, now you can customize these markers. Obviously, they're just image files. But if I click on a marker here, I can see the info window. If I click on another one, it closes that logic where it closes the current one, and so forth. So going back to the code for this example, 4A, what I've added is, after I draw the map, initial map itself, is a load properties function, which does the AJAX call. And then when the data comes back, obviously for each piece of data, I'm going to call the add marker function. So the rest of this hasn't really changed from the last example. So, it was just adding essentially this AJAX call and then just iterating over it. I changed the info window template slightly in this particular case, just to bring in the parcel number and the address. But that's another reason why you want to externalize that kind of stuff. So I told you that, when you do this by default, it doesn't zoom over. This might be something as you're working through mapping, you kind of realize, okay, well, now I wanted to zoom in on all the properties that I've just added. How do I do that? So that's the next example here with the same data, but this time I'm setting the map's extent, basically. So what happened is, as I'm adding each marker, there's a Google Maps API that you add each marker to, and essentially what it's doing is it's expanding out that bounding box for each marker that you add to make the bounding box big enough so it'll contain all the markers essentially. And then I tell Google Maps, okay, now using the coordinates of that bounding box, center the map on all the properties. This is something you're going to be doing when you do mapping of basically when you're mapping any more than one point. You're going to pretty much want to do something like this. So it's relatively easy to do this, to add that functionality. So this is demo 4B. It's the same exact code. The only thing I have is, after I load all my properties and lay them out on the map, actually, getting back to that for a second. Before I load the properties, I'm going to create this object here called lat-long bounds. So this is kind of the container that Google has to keep track of all the markers that you're adding, and is geographically expanding that bounds as you add each marker. So you can see here in the add markers function, as I add each marker, all I need to do is, on the marker bounds object, add that location. And basically, again, it's going to expand that box for me. Okay? So that's really it. And then after I loaded all the properties, so now that bounding boxes has been expanded, all I need to do now is just tell the map to fit bounds, basically, to fit that box, so I can see all the content at one time. So that's really all you need to do to move that extent.
Hey, Greg, I got a quick question.
Yeah, let me hold on. Go ahead.
Yeah, so if your marker bounds are sufficiently large enough, is the map smart enough to then zoom in or out to show just those bounds?
Yes. Yeah. So if you literally had a location in Europe and United States, it will zoom the map out sufficiently so you'll always see those two markers. Is that your question was?
Yep.
Okay. Yeah. So this is something you're going to be using a lot when you, like I said, when you start to get into mapping and you're mapping really more than one marker at a time. So the last demo I'm going to have on the Google Maps is, all I'm really going to do is, I told you that I'm loading 1,000 properties right now, which is a decent amount of properties, not a big deal. I'm going to bump it up to 10,000, and I'm going to start to show you where, doing the marker layout the way we're doing here we start to see some limitations in terms of browser performance. I don't know why this happens. some reason the first time. But, so this is where, okay. So you can see there was, that's actually a lot of properties. And this, by the way, just FYI, each one of these markers is a property that's owned by the city of Detroit that's either been abandoned or is going into tax foreclosure. So, and this is actually what my the client SDR is their product works with. They help these customers manage these properties, but it's kind of a scary picture there, right? I mean, it really does cover the entire city. Right now, there's 60,000 properties in that database. So this is a sixth of that. So interesting tidbit there. But you can see here, it starts to get a little slow. It's not too bad actually, but this is a fairly quick machine and so forth. But it's starting to lag a little. So there's a limitation when you start to work with Google Maps, or at least a mapping product, when you start to lay the markers out in the actual client itself, which is what's happening here. This is all being drawn on the client side itself. There's no server processing to process these markers for this example. So like I mentioned in the product we work with, thanks, Jeff. So in the product we work with, we're talking in the tens of thousands of properties typically that we're managing, and we start to hit these limits. So we needed to start to look for a slightly different approach to doing this kind of work, laying out markers and layers and so forth. So there's a couple of alternatives out there, and the one we actually zeroed in on is the product I'm going to talk about next. I'll just move over here, which is a product called CartoDB. CartoDB is a software as a service cloud API. It provides the full GIS stack and mapping tools. I guess in some ways you could say it's a competitor to Google Maps. It's a competitor to the product we talked about, ArcGIS. There's a couple others out there we'll talk about. The components that it includes is there's a web user interface for uploading, creating, editing, visualizations, exporting. So all that GIS functionality I talked about, they provide a fully web-based interface for that. They use the geospatial database they use is built on Postgres SQL and PostGIS. That's really important, especially the latter, the PostGIS. That's a really popular geographic API, GIS API that's used out there in the industry. And it follows a lot of the OpenGIS specification, which is a consortium that deals with all these GIS systems and tries to standardize across them. So the fact that Postgres has that module for PostGIS makes Postgres a really popular database to use whenever you're using any or going to do any kind of GIS type of analysis. I'll give a quick side on that. Is the product that we're using, developing right now for STR uses MySQL for the backing database. MySQL has a set of GIS or implements a set of GIS capabilities, but it's very limited, and it's also not optimized. They don't have geospatial indexes like Postgres and PostGIS do. So in hindsight, we sort of regret not looking at PostSQL and PostGIS before we started PostgreSQL. But at our stage in the game, it was a little too late. But this particular product actually hosts a PostgreSQL. God, I hate this word. PostgreSQL and PostGIS database for you, so you can utilize the full capabilities if you need to of those databases. They provide actually a SQL API, so they expose the database directly for you, as well as a JavaScript API to interact with the maps and the layers. And they also have on their server, this is a really important thing, they have a map tiler that works with the database, the SQL, and is able to be styled using something called CartoCSS. CartoCSS is actually not a product from CartoDB per se, but it's a open source standard, I guess, for stylizing maps. So when I want to, for example, stylize a marker, change the color, or stylize polygons or features on the map, I'm going to use this CSS-like language to do that, which makes it really easy to do. So CartoDB is available as a freemium hosted service, or you can actually deploy it yourself using the open source code. We haven't done the latter at this point. We're actually using their paid service, their paid hosted service. But it's an interesting option that they do have the open source code. Actually, this product's written in Ruby and Rails. So, you know, that might be something we could look at down the road. It's a really high performance geospatial analyst tool. It's got a lot of caching in there. It's using Postgres and the databases and so forth. And it's able to process and visualize large, very large data sets, which is one of the reasons we chose it. So we're going to switch over basically, actually, before I do that, I'm going to just show you the interface. So this is doesn't fit too well here. This is the CartoDB web interface. I'm logged in, and you can go ahead today and sign up for an account on this. You get I think a 50 meg database area. You can create 5 tables and start to play with the mapping for free. But this particular table here, I brought in the data from the Detroit parcels, and you can see when I click on it, you know, I'm going to see a table view. Essentially, this is the PostgreSQL view of the data. So you can bring in, you know, data that's related to the geographic data that you're bringing in. So here you see the property address, the parcel number. So you have a full SQL console here. So anything you can do in PostgreSQL, you can do here to play around with your data and to select. So this is really where the data-driven part of this comes in. You know, I can really filter down on my data using SQL, sort my data, and in a minute, you know, find things through the database and present it on the map. You see here, there's a column that's always included in these databases called the geom. So this is what they call the geometry. So essentially, this is going to be your feature. So this is your point or your polygon or your line that's associated with the data itself. So this is really the part that you're going to map. So in the tool itself, you can quickly switch over to the map view, and they'll visualize that data for you right here. You could use Wizard, so you can quickly, this is not really good in this resolution, but you could really stylize your map very quickly. So I can create clusters, which is really kind of cool. So you see here, it clustered together my property. So there's 5,300 some odd properties in this location. So this just makes it easier for the user to visualize that area. You can categorize by color different properties if you had some sort of categorization column or values you want to aggregate over. And then you have full access to the Carto CSS itself. So you see it's kind of expressed like CSS. So it's familiar to web developers, but it uses its own type of language to express that. So we're exposing this in the SDR product to allow the customers to, or I should say we put a UI over this, but this is basically how we allow the customers to customize their maps. So this is all nice. You can visualize in this tool and everything, but what I think most people, at least what we're doing, want to do is integrate this into your application. So, so that's what we're going to show now, a couple examples of that. So switching to the next sample here is using CartoDB to visualize those same, I think, 10,000 properties. So you can see here how quick that was compared to doing that with the Google Maps. Okay, I mean, that's like instantaneous. And it really did do a query on the database and visualize all that data. The big difference here is these points are no longer being rendered directly in the browser itself. Instead, they're being returned as layers that are being layered on top of this base map. So as a quick demo, let me just refresh this. I'm looking at the Google console here. So if I scroll down into the tiles that are being returned, I can find a few good ones. Maybe where are they? You know what? It's because I'm zoomed out so far. Let me zoom in a little bit. All right, well, here's an example. You see, here's a tile. It's with a transparent background, and it contains just a few properties here. And if I took that, you know, that's going to line up somewhere on this map with the property. So that's the tile concept in action. So CartoDB, when you query this, is actually querying the database, finding the properties themselves, pulling out the geography information, the geographical information, the points in this case, working through its map tiler to actually generate that image on the fly, optionally caching it, and they have a CDN too, which makes the edge caching a lot faster, and then returning it to the browser for the correct coordinates. And then the browser API is actually laying it on top of the Google Map base layer itself. So you could have, example, that was just one layer, but I can actually layer on as many layers as I want on top of this to kind of stack it up. So here what I did is I have a little menu item here called Show Future Use. So this was a layer I downloaded from the Detroit public website itself, the city of Detroit, that's showing the future use areas for the city of Detroit. So if I zoom in a little bit here, you can start to see the layers laid on top of each other. So here the properties are underneath in this particular case, and then on top of that are these color-coded layers. And I can see here that's low, medium density residential. So this is, again, using the maps to express information really quickly and visually for the user instead of them having to work through a big grid of data and so forth. So really powerful stuff here. And then again, you can hide the layer, and you can see how quick that is to respond. And that's a fairly large file too if we go back to look at the table. That's in this future use table. I think this is fairly large.
So Greg, was the difference in performance due to the fact that in the Google Maps example, you're individually creating each marker on the map versus the CartoDB, where you're basically getting all of the information in one fell swoop from the database and then creating a layer? Is that? Yeah,
that's some aspects of it, the fact that you have to render each marker on the map directly, and that's all being drawn on the client side for Google Maps. The other difference, though, is that obviously Carto is returning those as tiles, so it's just one image. So we'll do a lot of caching as well on the back end. So if you execute that same query again and none of the data has changed, it's going to cache those tiles, so it doesn't actually have to go through the query and so forth. It just returns the image directly. So actually, this is not showing too well in this resolution. So anyway, just in the interest of time, let's just show the code that was used to do that for that CartoDB map. So again, this part of it hasn't changed at all. I'm using Google Maps now as the base map. So this is where we talked about the base layer before. So Carto also is able to interact with the Google Map API. So you don't have to throw away all you know about the Google Map API. It actually works with the Google Map API. It works with other map APIs. There's another open source map API out there called Leaflet that's really popular. So it works well with that as well, in addition to the Google Maps. This code here is just adding that little menu item I had on the top. So it's just a Google Map. So here's where we get into the Carto code itself. So here I'm going to just establish a connection to the Carto database, quote unquote, using the SQL object, passing in my user. And then I'm going to load the properties. So this is going to be a little different now than what we did earlier. We loaded it from JSON earlier into the browser. Instead here, I'm going to tell Carto to create a layer, which is basically its base layer on top of the Google Map layer. And layers, it's got this concept of sublayers. So these are all the different layers you can add into or on top of the Carto maps, the layers that come back. So in this particular case, I'm going to add a sublayer. And the way you interact again with the data is really directly through SQL. So if I go over to my file here where I have the SQL, you can see that all that is doing select star from Detroit parcels, the table of Detroit parcels. So it's really easy to use, real familiar for developers. I'm going to pass in the CSS used to render the map features. So we saw a little bit of that, but essentially I'm going to tell it how I want those markers to be colored and filled and so forth. And then that's it. Well, I'm sorry. And then there's this last interactivity. Basically what this tells Carto is that I want it to bring back or expose these properties as data so I can use them either in the info windows or in my client-side code itself when I click on the markers. So as that's churning through, it's going to call a callback here when it's done. And when it's done, all I need to do, very similar to the Google Map API, just doing it slightly different, I'm going to add a feature click callback onto my sublayer that was rendered. And then basically this is going to do more or less the same thing with the info window, just slightly different way of executing it. And then after I do all that, I'm going to do the same thing that I did with the Google Maps, which is updating the extent of the map so I see all the markers, except this time I'm going to do it using the CartoDB itself. So essentially what I'm going to do here is execute a function, a SQL call. So if we go into that, this is where it gets a little bit into the, where did I put that? Oh, I'm sorry, it's the same SQL. So basically I issue the same SQL to it. So I'm telling it all the properties. But Carto provides a get bounds function for me that actually generates the post-GIS SQL that'll find all the properties within, or give me the bounding box for all the properties that were selected. And then once that's returned, I use the same code we saw earlier, the Google Map lat long bounds, and I set that to the box that was returned by CartoDB, and I tell it to fit the bounds. So again, all these concepts are very similar in any of the map APIs you're going to use, even if it's not Google Maps, or that you're going to encounter this kind of same code over and over again. So, and this is all basically boilerplate, just doing all the info window stuff. So the next demo, because I know we're running really short on time here, is actually the cool stuff. We did all that. Now we want to start to do some of the data-driven API. So what I'm going to do now is I'm going to select one of these markers, and I added this search radius combo here. Actually, this is a slight bug in my code here. Search radius, and I want to tell it to search for all the properties in a 2.5 mile radius from this location and return those properties. So you can see now all that was calculated on the server side using the database and a SQL call, and it returns all the properties that were inside of that. Basically, you can almost see the circle here. I think I selected this property. So this is going to be, this is when you start to go on websites, find me all the stores located in my area. This is when you start to get into more of the GIS type of function. So the way we do that, going back to the code, is again, same thing. All the code is the same. What I did is add that combo box, and on the select on the combo box, it's going to call this doRadius search function. The doRadius search is going to get the location of the marker that's clicked. It's going to convert my selected value in the dropdown from miles to meters. A lot of times the GIS coordinates is going to be more meters based than metric based than miles. So anyway, that's something you'll end up doing. But then what I'm going to do here is to my base SQL, the select star from Detroit properties, I'm going to add a GIS function here, which is basically this st underscore function. All of the geometry functions in PostGIS begin with st underscore. So if you see those, that's what you're looking at. And basically what this is saying is within, let me see if I can figure this out again. So this is the selected value from the database when it's looking at all of the geometry. Within this point location, given this radius, find all of the locations that are contained within that radius, basically that circle, and return it. So you can do this all through SQL. If I issued this, you could get back all the rows. But by doing it through Carto for the SQL, what it does is then I set it on the sublayer here, it's going to go ahead and execute that SQL, and for the result set, render all the points essentially on the map that were returned for that query. So that's that's really kind of neat.
What
so
are some
taking
of those,
that example, hello?
hey, what are some of those constant integers that were in that SQL call?
Yeah, I knew you were going to ask that question. All right, so this is where it gets into some of the hairy geography components. So this ST transform and this 2163. So I'm not an expert in this area, but basically what these are SRIDs, which are spatial reference IDs. What this essentially tells the GIS system is what kind of coordinate system am I using when I pass in these values, okay? Because these don't have to necessarily be lat and long. They can just be X, Y, or they can be another coordinate system. So I think it's the 21. No, I'm sorry, it's this one. The 4326 is the standard for lat and long coordinate system. So essentially, this is doing some transforms from the value that's coming back from the Google Maps to the coordinate system I want to use. But that's essentially what's happening here, is you're telling the GIS system, how do I treat these coordinates that I'm passing in? Okay, so the last example I want to show you is searching by custom areas. Why is this not rendering? Oh. It's demo 7. All right, so this is kind of cool. Now I've exposed the Google Map drawing manager, it's called, where I can start to draw polygons and circles and so forth in the map. So what I can do here real simply is just draw a circle and bam, query on it. I could actually drag this circle around and you can see it's actually doing a database query, getting all the points, mapping the points. So I'm finding, all these different areas on the map. I could draw a square. I can draw all the different kinds of shapes and map that location. So the customers that we have on the SDR product love this feature. What they typically will do is draw lines around areas, neighborhoods and so forth. But the principle is really more or less the same in the code. We've expanded a little bit. First of all, we're initializing the Google Drawing Manager, which again, this is part of the Google Maps API itself. And then after I do that, there's a overlay complete event that's triggered once I'm done drawing. And based on that, down here, what I'm doing is getting essentially based on the type that's drawn, let me make this a little bit bigger. Based on the type that's drawn, the circle, the rectangle, or the polygon, which is what we support, we're going to execute different PostGIS functions essentially to select the area. So we already saw the circle one, so I'm not going to go over that. The rectangle is really just a simple bounding box. So all I need to do is get from the shape that I drew is to get the northeast and the southwest corners, and then use this intersect function. So I'm intersecting each of the geometry in the table with a 2D box essentially, a 2D box function here that I make from the southwest and northeast coordinates to draw that box. So essentially it's going to find all of the points within that box using this intersect function. And then the final example is the polygon, which is going to contain many points. And again, what I'm going to do here is tell PostGIS to render a polygon from all those points that I generated, and then find all of the points or the geometry within that table that lies within that shape itself. So here you can draw an arbitrary shape, which essentially is a polygon, and find all the points that are contained within it. So there's actually 3 probably really good PostGIS functions or geometry functions to start with. Those will probably satisfy quite a few of the things you'll need to do. I mean, there's not thousands, there's probably hundreds of different functions that are available for really more sophisticated type of analysis that's really beyond what I've gotten into. So I know we went over a little bit, sorry about that. So really, to end this, there are a wealth of GIS and mapping functions and capabilities out there. These are just a few others I'll mention. There's something called Google Fusion Tables, which is actually very similar to what I showed, the functionality from CartoDB. It has a database or some sort of table system and the ability to lay out layers and so forth. But here's again where we get into some of the Google interesting limitations. They limit the number of rows in the table. Then they start to charge you an obscene amount sometimes for the server license and so forth. So we ended up not going this way, but it is a popular option out there. The Leaflet API, like I said, is an alternative client-side mapping API that people are using. Mapbox is a competitor to CartoDB. It does a lot of the same functionality. We actually ended up choosing CartoDB over Mapbox because we wanted the raw database capability or exposed, and Mapbox doesn't expose all that to you. I mentioned the tool Esri and ArcGIS, which if you do anything with enterprise mapping, you'll run into this product, but fairly expensive commercial product. And then of course we talked about PostGIS. I guess that's it. So is there any questions?
That data that's not latitude,
The data itself?
Yeah.
It's actually, if you go to the GitHub site, you'll see the data. You can play with it yourself.
Oh, okay.
Is that what you're asking?
The longest that is, for example,
Oh, where did I get that?
Yes.
Okay, that's a good question.
Yeah.
There are several websites out there that essentially what they do is they just write a small API on top of the Google map, and you can just click on a location, and it'll return you. I don't know. There's a few I can get you URLs, but you can just Google it and find that. But that's how you would start to do that.
Your iPhone will tell you too.
Yeah,
If you're there.
that's
Yeah,
true too. Yeah.
There's apps that'll tell you.
All right.
Very good. Amazing. Thank you.
All right. Cool.
Good job.
Thanks. Hit that.